Good evening, guys. Guys, just confirm you can hear me and my screen is visible.
Yeah, visual, sir.
Okay. We'll just see maybe 2 more minutes if more people are joining. Still, people are coming. Okay. So in the last class, we were discussing refrigeration. We have studied a few things. We have studied the basic definition, then TS ka, pH ka, what is critical temperature, critical pressure. Like that, we studied many things and we studied different component. Now we'll go ahead. How to achieve perfect alignment? We did this one, right? Guys, we already did how to do the perfect alignment, right?
Yes, sir.
Okay. Next is what will be the consequences if your V belt is misaligned? I think already did, right? Okay.
Yes, sir.
Okay, then we'll go ahead. We did this also procedure. So next is suction wall. Suction wall and delivery wall both are incorporated into the same thing in the same structure, right? Can you
Yes,
see
sir.
down? This is the suction wall, and on top there is a
Yes, sir.
discharge, and again safety spring. If
Safety.
yesterday somebody was saying something like if trip is not working, then right, then this
Yes,
safety spring is also there, right? It will lift. It is going to lift then. Clear?
yes,
Then it will open your discharge wall. There is a wall plate under the cylinder head, and the plate type of suction wall and discharge wall is located in it. Why plate type? Why plate type? Even I think they are asking this question in compressor as well. Why plate type? Okay, what all think you can think when you are thinking your normal valve and plate type valve? If you are having normal valve, you need something them to lift, right?
Yes.
You need rocker arm, you need push rod. Can you imagine how many component you are increasing?
Yes. Many components pushing. Yes.
Whereas when you are using this plate type valve, they are opening and closing only by the
One sitting surface
pressure,
only. Yes.
pressure difference, right? When your piston is going down, pressure is decreasing, so valve will open. When piston is coming up, pressure increasing, this will close, correct?
Yes, sir.
And apart from all those things, large diameter and very small plate lift offer least resistance to the flow of refrigerant. So when you are using this type of valve, you are facing the least resistance. Heavy spring on the discharge valve cage permit a greater lift to the protect the compressor in case of the liquid refrigerant or oil pumping. So if there will be any oil or liquid refrigerant, that is incompressible, right? So your pressure will increase like anything, then this spring will lift.
Yes.
Okay. Next is oil separator. Clear suction valve working.
Yes, sir.
Next is oil separator. So can you see this diagram? From here the oil is coming, the refrigerant is coming from the compressor, hot refrigerant, it going at the bottom. Then there are
To tank. Yes.
plates,
Yes.
there are plates, your refrigerant is passing on from this and finally going up and coming out from the top. And on the bottom there is one float
Float.
valve. When level is high, this needle valve will open and oil will go into the
Tank. Yes.
crankcase. Oil separator. It is a closed vessel fitted with a series of baffle or knitted wire. There can be wire mesh also. Okay, not only baffle, there can be wire mesh through which oil laden vapor pass. The reduction in the velocity, the reduction in the velocity of the vapor as it enter the larger area of the separator allow the oil particle which having greater momentum to impinge on the baffle. They will strike on the baffle plates or wire mesh. The oil then drain by gravity to the vessel where a float control valve is there, and then it's finally going back to the compressor. Clear?
Yes.
What is the location of the oil separator in the refrigerant cycle diagram? What is the location? Before compressor
After compressor, sir.
or after condenser?
So after condenser, sir.
Guys, after compressor or after condenser?
After compressor, sir.
After compressor, after condenser, dryer will be there.
Very good. Only after compressor. Then the next one is dryer. Why we need dryer?
Remove the moisture from the system
Why you want to remove the moisture?
because moisture it cause frosting. Yeah,
Frosting at the
blockage and
expansion
malfunction.
wall.
Yeah, malfunction expansion.
Okay. So refrigerant will be passing from this direction. It is having different filter, coarse filter, then felt filter, fine filter, then drying element, then finally clean dry refrigerant is passing. Coarse filter is removing the large particle, fine filter removing the small particle, and drying agent silica gel or activated alumina will be there. So they are absorbing the moisture. Have you seen manual valves on the compressor? In the refrigeration system, have you seen the manual valve?
Valve, sir, for no manual valve, sir.
No manual valve. How do you collect refrigerant?
By sir, shut down the evaporator condenser outlet.
So
By
that is a
closing
manual
the
valve, right? You are closing one valve on the condenser outlet. So that is a manual valve, correct?
Yes.
And there are
yes, sir.
many manual valve. Suction, discharge, right?
High charging, refrigerant charging.
Refrigerant charging, pressure gauges, lot
High
of
charge.
manual valve are there, okay? Purging line. So manual valve, what is the speciality of these manual valve? Any special feature? So what happen in our engine room valves when we are opening them? When we are opening them, you must have seen they are leaking from the glands.
Yes, sir.
Can we afford same leakage here? You can put those valve also, right?
No, sir.
Why?
No, normal manual we cannot put, say, because leakage will start from.
So then what is the benefit of these manual valve? They are back-seated manual valve. What does back-seated mean? Can you see in the diagram? Can you see in the diagram? The valve is closed. Okay. The refrigerant is coming from here, or you can take any direction from here. Let's suppose it's coming from here. So valve is closed. Nothing is passing in this side, right? So now you have opened the valve. Can you see this area? This area. Can you look at my pointer?
Yes.
This is
Yes, sir.
also a seat. So when you are going to open this valve, this seat will sit here. So you will get positive closing by the seat. When they are on back side, on the back side also they have the seat. When you fully open them, they will seal here. So nothing will leak from the glands. Clear?
Yes.
All of you, clear or not? What does back seated means?
Clear, sir. Clear.
They have two seats, one in the front. Front seat seals when they are fully closed. Back seat seals when they are fully open. So
Open.
that's why you must have seen we never throttle the valves. Either we are keeping them fully closed or fully open. Okay. Most of the
Yes.
valves used in the refrigerant system are packed valve type. They are back seating type. When in open position, the valve is back seated to the minimize possibility of leakage. So when they are open, they are having seat at the back so that there can be minimum leakage or no leakage. Next is condenser. Condenser can be seawater cooled or freshwater cooled. Refrigerant will be where?
Refrigerant will be flowing outside.
Outside, and seawater or freshwater will be
In
in the
tube.
Inside
tube.
the tube.
So can you see seawater is entering or freshwater is entering in the tube? Then from here they are double pass going up from the top, refrigerant coming from here, and refrigerant out from bottom. Why out from bottom? Why not?
Because if sir
They can
air will
provide out from top also, right?
what, sir?
Refrigerant outlet on the condenser is from bottom in this picture. It can be on top also, right? Doesn't
Never
matter.
I never
Okay.
seen such this type.
We can change this as inlet and outlet on the top, right?
Yes.
Yes.
But sir, anything will happen with the structure.
So suppose you are making bottom at the inlet and outlet on the top. So what happen in the condenser? Your gases are converted into.
Liquid.
So how you will take out liquid from top? Liquid
Yes.
will be at the bottom only, right?
Yes.
Yes.
That's why our condenser always have the refrigerant
Bottom.
coming from
Outlet.
top and outlet at the bottom.
Bottom.
Seawater is circulated through the tubes and hot gas from the compressor discharge is admitted to the shell and the condenser of the outer surface of the tube. So one question surveyor is asking how to increase subcooling in the condenser. How to increase subcooling?
Cooling the regulating flow of a
You are
cooling.
using seawater or fresh water here,
Yes.
right? How
Yes,
to
sir.
increase subcooling? Hmm? So for increasing subcooling, what they are doing, this was our suppose evaporator. Okay, this was the evaporator. Refrigerant coming out of the evaporator will be cold or hot?
Hot, sir.
Hot. How much hot? Have you ever touched?
Not that much hot, but it will become a gaseous state. Not.
Gases, but how much temperature? Have you seen sometime icing on the condenser compressor inlet?
Yes, sir.
Sometime
Yes,
water
sir.
is
Yeah.
dripping. So how it is
Yes,
hot or
sir.
it is cold?
Cold, sir. Cold.
Cold, but in the superheated. It's hot for the when you're comparing to the refrigerant. Now
Yes.
compare this hot refrigerant, what you are saying hot, but actually its temperature may be 2-3 degree or 4 degree, right?
Yes,
Yes.
sir.
And what is the temperature of seawater or fresh water we are using in engine room?
Depends
30.
on, sir.
Fresh
Plus
water
your
Depends.
temperature.
normally 30, 20 we are maintaining 20 to 25, 30, right?
Yes.
So what they are doing, one line before going to the, this is the evaporator. From your evaporator, where it leads to. From your evaporator, refrigerant is going where? Outlet.
Suction side of compressor, sir.
Compressor, right? So they're taking this line and passing this line to the condenser. Okay. Then it's going to the compressor. So now your condenser efficiency will increase or not?
Yes, it can increase, sir.
It can increase, right?
Yes.
Clear, guys? How to increase the efficiency of the condenser? They are asking this question.
Once again, sir.
Our refrigerant is coming out from the evaporator. Okay. And evaporator, when they're coming out, their temperature sometime is 2, 3, or 4, 5 degrees Celsius, that much only. So what they do, they are making one more line in the condenser. We cannot do it on board. It should be from the yard only. Okay. We cannot do on our own. So
Okay.
they are making one more set of coil, maybe tubes like this, where refrigerant is going in the tube, right? Now when
Yes.
they are coming out, so your condenser efficiency will increase, right? When you are putting seawater may be sometime 30 degree, correct?
Yes, sir.
But refrigerant is 4 or 5 degree. So we are increasing efficiency. Or you can do like this, maybe bottom 3 tubes you are using for the seawater or fresh water, top 3 tubes you are using for the refrigerant, right?
Okay.
So in this manner, we can increase the efficiency. That is for the design state, but no, we cannot do anything on board. But they are asking in the MMD how to increase subcooling in the condenser. A suction gas heat exchanger is placed in the bottom of the condenser inside the tube. This secure the compressor gas. Same thing is written. Next is liquid receiver. What is liquid receiver?
It is fitted after condenser, sir. If you're doing any maintenance, air air purging, that times we collect or represent in receiver.
Liquid receiver collect refrigerant coming from the condenser.
Condenser.
Side glass or liquid level indicator is there to determine the amount of refrigerant present in the system, and sometimes bottom of the condenser act as a liquid receiver.
Sir, most of the ship having this condenser, only the liquid receiver, sir.
Yeah, bottom part of the condenser they are using as a receiver. Next is liquid indicators. The liquid indicator or side glass are commonly installed in the liquid line to indicate a proper refrigerant charge. The bubble appearing, if you can see the bubble in the line in the liquid stream, are the indication that there is shortage of refrigerant. So they indicate that there is shortage. Not only that, some indicator also include a moisture indicator. A portion of the indicator will change color and based on the relative moisture of the refrigerant. Suppose your dryer is not working, how you will get to know?
Use a liquid indicator.
Yeah, when they are dry, their color is green. So if it's changing to yellow, that means your dryer is not working. Clear? And if you can see bubble in the liquid indicator, that means the charge refrigerant you have to charge. Then we will discuss about evaporator. The unit consists of a cooling coil with fine tube, a motor driven fan, and the drain pan, all enclosed in a sheet metal casing. Unit designed for sub-zero temperature application are usually fitted with the electric defrosting system. We already sorry guys. We already discussed what is defrosting, right? How defrosting is taking place? Who will tell how defrosting taking place?
So there will be, sir, automatic, sir, heating coil arrangement will be there, sir.
There will be one timer for defrosting. When the timer is activated, defrosting cycle will start and it will de-energize the solenoid for that compartment, right? The solenoid which is sending refrigerant to that compartment, and it will give start signal to the heater, correct?
Yes, sir.
So next is what should be the lubricating oil property? We can use any oil or there is some specific oil we have to use for the reefer plant, or we can just put anything.
There will be properties will be need because the refrigerant is very low temperature, sir. For that dual should be the pour point. The resistance to flow should be minimum temperature where that dual can be sustained. That kind
This
of.
is also a very important question they are asking. Okay, what is the property of refrigerant oil? Oil come in contact with the refrigerant and its miscibility is an important factor. The oil being hydrocarbon would normally is very immiscible, so very miscible with the furon and its working temperature range. Oil is carried over from the compressor, but most of the oil is returned periodically to the from the oil separator. This means that level in the sump is in a balance between oil circulation and oil in the machine. The separator is never 100% effective, so some oil always go into the system. After the condenser, oil present in a solution with the liquid refrigerant, preventing the deposition of oil on heat transfer surface is the main problem. That's why we are putting oil separator. We don't want oil to be go all over in the pipeline. A buildup of deposit oil will be seriously affect the heat transfer. I forgot to add lubricating oil properties slide in this. We'll discuss that later. Please write down that question and remind me later on, okay? Or put in the group. The evaporator coil size is usually designed to ensure high enough flow velocity of the refrigerant to enter the oil, to entrain the oil. At low flow, the oil will be deposited and hence some of this type of contamination will occur. As the oil reaches the cold part of the system, it is essential that its behavior at low temperature does not affect the plant. That is, oil must not congeal, hence its pour point and viscosity must be correct. So you can write down the property viscosity. First one is viscosity. Viscosity,
Viscosity and 4 point.
viscosity measures a fluid resistance to flow. Viscosity, when we say viscosity, it's a fluid resistance to flow. Resistance refrigerant oil need to have an appropriate viscosity to ensure smooth circulation within the system. If the viscosity is too high, it can reduce the heat transfer, and if viscosity is too low, then there can be damage of,
Evaporator coil also.
yes. I'll just put the slide like this. You will not be able to understand. I'll just put the all the points. I'll just name the point. Then in the your Telegram group, I'll put the points. Okay, I'll put the slides. Viscosity, chemical stability, thermal stability, low pour point, compatibility, solubility, and chemical inertness. These all properties should be there. Either we'll discuss tomorrow or I'll put in the group. Next is shaft seal. Why we need shaft seal?
Because in that in this AC refrigerant compressor, the system is that it takes suction from the crankcase, sir. For
Yes.
that, we need the shaft seal. Otherwise, this gas will be leakage from the shaft seal.
Very good. A mechanical seal is fitted around the crankcase at the drive end of the crankcase. This prevents the leakage of oil and refrigerant from the crankcase. All seal use two rubber surfaces, one surface turned with the crankshaft and is sealed to the shaft with the o-ring and the synthetic material. The other surface is stationary, same like our mechanical seal, right? Stationary and mounted on the housing with a gasket. The rubbing surfaces can be hardened steel, bronze, or ceramic or carbon. The mechanical seal is lubricated from the compressor. Now we will discuss about expansion wall. What is the function of the expansion wall?
By it's reducing the pressure, it's decreasing the temperature, sir.
It is reducing the pressure and
And the temperature.
temperature. This effect is known as what effect? Kumar, you were there that time, right?
Yes, sir.
What effect? Joule
Expensive also.
Kelvin. Joule Kelvin. Do you remember? Joule Kelvin effect, forgot?
Yes, yes. Yes.
Do you remember this?
Yes, June.
Okay. So the basic function is reduce pressure from condenser pressure to the evaporator pressure. It regulates the refrigerant
Flow of refrigerant.
from high pressure liquid line to the into the evaporator at a rate equal to the evaporation rate in the evaporator. Why we need same rate? So that only vapor will be passing, right?
Yes.
Yes, sir.
Under ideal condition, the mass flow rate of refrigerant in the system should be proportional to the cooling load. It is desirable that liquid liquid refrigerant should not enter the compressor. In such case, the mass flow rate has to be controlled in such a manner that only superheated vapor leaves the evaporator. Clear? What is the function of the expansion wall?
Yes, it maintaining the degree of superheat.
Degree of superheat. So this is the basic thermostatic expansion wall looks like. There is a bulb pressure acting on the top. Can you look
So
at the diagram?
yes, sir.
Then saturation pressure acting from the
From the
bottom,
bottom and a
and we
spring
have one
pressure.
spring,
Yes, a
right?
spring pressure.
Spring pressure, and if bottom two pressure is more than top, then wall is closed. Otherwise, wall will open when bulb pressure
Okay.
will be more. We'll just study how. Thermostatic expansion ball. The TEV strives to maintain a stable level of superheating. So TEV try to maintain the stable level of superheating inside the evaporator under all conditions so that no liquid can enter inside the suction wall of the compressor by adjusting the mass flow of the refrigerant in response to the evaporator load. This is achieved by a membrane inside the wall housings. This is the membrane. The pressure generated above the diaphragm is saturation pressure corresponding to the temperature of the bulb. So here one pressure is acting, that pressure is acting because of the pressure of the bulb, right? And this bulb is attached to the
Outlet of evaporator.
outlet of evaporator or suction line of the
Compressor.
compressor. So when the temperature increase, the bulb
Bulb
pressure
will
will
liquid
increase
expand. Yes.
and the pressure will increase, right?
Yes.
Equalizing pressure pipe is taken from evaporator inlet or outlet. So on the basis of inlet or outlet, we can say the TV is internal or external, right?
External. Yes.
What is the correct name? Internal
Thermostat
internal
equalizing and
equalizing
external
or
equalizing.
external equalizing. Okay. If the evaporator is operating with no superheat, the pressure above and below diaphragm will be
External equal.
equal
Equal.
and valve will be closed. The difference in pressure between the saturation pressure of evaporation and the pressure of the bulb is balanced across the membrane inside the head of the wall. The movement of the membrane control the position of the needle. So it's controlling the position of the needle and hence mass flow of the refrigerant entering the evaporator. So what is the medium in the bulb?
Same as
Same
refrigerant, sir.
Same as refrigerant. Okay, normally same as refrigerant. The thermostatic expansion valve respond to the evaporator temperature and pressure and maintain a constant superheat at the outlet of the evaporator. As the refrigerant is fed to the evaporator, the liquid boil off into the vapor. By the time refrigerant gas reach at the end of the evaporator, it is superheated. Feeding more refrigerant to the evaporator will lower the superheat temperature, while feeding less refrigerant will raise the superheat temperature. Clear this much?
Yes, sir, clear, sir.
This consists of a filler bulb that is attached to the evaporator exit tube so that it senses the temperature at the exit of the evaporator. We already discussed this. The filler bulb is connected to the top of the bellow. Can you see? It's connected to the top of the bellow.
Yes.
There is one diaphragm. It's connected on the top by a capillary tube. The filler bulb and the narrow tube contain a fluid that is called as power fluid, and normally is same refrigerant. To ensure the correct operation of the valve, the bulb must be secure clamped to the evaporator outlet line. So it must be on the evaporator outlet line. Now we will see working. There are three pressure acting inside the thermostatic valve. P1. P1 is the pressure acting at the top of the thermostatic expansion valve, acting inside the power element above the diaphragm. So now if it temperature is increasing, liquid will try to expand and pressure will increase and P1 will increase, right? Due to this pressure, the diaphragm tend to move down. So if P1 is acting on the top, so obviously the diaphragm will try to move down when the temperature will increase, right?
Yes,
Yes.
sir.
As a result, needle moves down and valve tend to open. Can you see this area? When needle is coming down, this valve is opening, right? The liquid
Yes.
is having inlet from here. Now, right, when the valve is closed, it's only in the bottom side. But when valve will open, it will follow this path,
Operator, sir.
right? And it will go to
Yes.
the evaporator. Clear? P2 is the pressure acting on the lower side of the diaphragm due to the refrigerant pressure inside the evaporator. So can you see there is one internal equalizing port? Can you see this area?
Yes, sir.
And there is
External.
one hole. So the pressure is going from here. P2 pressure is going from here. Clear?
Yes.
Due to this pressure, diaphragm tends to move upward to close the valve, and the spring pressure tend to close the valve. So P3, can you see spring pressure is acting
Yes.
against the valve? So it
Yes.
also want to close. So there are two forces to close, P2 and P3, and P1 wants to open. The
This is
pressure,
internal equalizing. This is internal equalizing, sir. Lines.
yeah, this is internal equalizing. It's coming from inside the thermostatic expansion valve, right? Equalizing
Yes.
line. The pressure P2 and P3 act against the pressure P1. The pressure P1 tend to open the valve while the pressure P2 and P3 tend to close the thermostatic expansion valve. Thus, if the valve has to open, P1 should be less or more.
Is to open the P1 should be more, sir.
P1 should be greater than P2 and P3
Yes.
total force.
Yes.
During the normal working of the refrigeration plant, the thermostatic expansion valve remain open in certain position. When the refrigerant load increase, the temperature inside the evaporator also increase. In such case, there is a need of more refrigerant to take care the increasing load. The increased temperature in the evaporator sensed by the filler bulb of the thermostatic expansion valve, and this lead to expand the gases in the filler bulb and also in the power element of the TEV, leading to the increase in pressure of P1. Due to this, the diaphragm of TEV moves down. Diaphragm of the TEV will move down and tend to open the valve further to increase the flow of refrigerant to the evaporator. At the same time, P2 below the diaphragm also increase due to the superheating of the refrigerant inside the evaporator. So P2 will also increase because your refrigerant which is coming out from the
compressor.
Evaporator is also increasing, right? Because this is directly connected to evaporator, same pressure, right? This pressure tend to close the valve. The spring pressure P3 act below the diaphragm to oppose the opening of the valve. If the refrigerant lead to increase P1 will become more than the P2 and P3, leading to further opening of TEV. This allows the more refrigerant to flow through the evaporator to meet the high load demand. When the load reduce, the magnitude of P1 reduce and combined pressure of P2 and P3 try to overcome the pressure P1. So now suppose the meat room or fish room is already cooled. So what will happen? Your filler bulb temperature will also go down and then it will P2 and P3 will close the valve. That allows the valve to move in the closing direction. As a result of the flow of the refrigerant reduced to the evaporator. So TEV maintain a flow of the refrigerant inside the evaporator as per the demand. The TEV constantly modulates the flow to maintain the degree of superheat for which it has to be adjusted by the spring. So if you want more degree of superheat, you are open or you are going to close the spring. You want more degree of superheat. What you are going to do?
Close.
Close. You are going to increase the spring tension.
Yes, increase tension, sir.
This is external equalizing. Can you see equalizing line? In the
Yes,
other
sir.
one,
What?
this line is going from evaporator and they made one small hole from here. So this pressure is acting, right?
Yes.
Internal pressure was acting only. But
Yes. So
in external equalizing, they have taken from outlet of the
evaporator.
evaporator. And these are required in the long evaporator or large evaporators. Okay. Because suppose your evaporator is only maybe say uh, half meter long, maybe you can say quarter meter long, then the pressure drop will not be appreciable at the suction and the discharge of the evaporator, right?
Yes.
But suppose your evaporator is 2 meter long, so obviously there will be some pressure drop.
Yes.
That's why when your evaporator becomes big, we are using external
External
equalizing
equalizing line
lines, okay,
for compensate the pressure
for
drop.
compensating the pressure drop in the large
Large
evaporator.
evaporator.
TV with external equalizing connections, there is a pressure drop in large evaporator. So there is a pressure drop in the large evaporator. That's why we are using
TV
TV
external type.
with external equalizing connection. Additional
External
control is introduced by incorporating external pressure equalizing line.
line.
The longer the length of the evaporator will result in pressure drop inside the evaporator. Saturation temperature will drop. Saturation pressure temperature will drop. Liquid boil off itself, then evaporator will starve.
Star.
By external equalizing line, P2 pressure will drop and TEV will allow more refrigerant to flow through the evaporator. So there are chances in the large evaporator that you are starving. Your evaporator will start for the refrigerant. Working is same. No need to tell again, right?
No, sir.
Bulb pressure on the top, then spring tension, and then external equalizing line, right? That's all remain same. What should be the location of the external equalizing line? So what should be a location? It should be here or it should be here. Can you see
After
my
sir,
cursor?
yes,
Before,
after sir, after bulb.
after bulb. Why? Why? Okay. What should be location of external equalizing line? The location A, B, and C all are acceptable. A, B, and C all are acceptable if pressure is same at all operating condition. But what is the reason? In past, there has been some concern about installing the external equalizing upstream of from the bulb. Upstream of the bulb, they have faced some issue. This is due to the possibility of refrigerant leaking past the TUV push rod. Can you see push rod? It might be possible some refrigerant is leaking from here, right?
Yes,
It can leak, and this is at high pressure, right?
yes,
Passing through the equalizer line and in the suction line. So what will happen? It will go from here to here, right?
yes,
And falsify the influencing the TEV temperature bulb. So if this line will be here, suppose before, if it will be upstream, it will be before. So what will happen? The temperature, if small leak, obviously the pressure will not affect much in the line, right?
yes,
So what will happen? The temperature, here it was maybe 4 degree, but how much is the temperature here? Low, maybe -2, right? Maybe -17, maybe -16, right?
yes,
So the wall line will be at -16, same temperature. And what bulb will sense? -16, right? At -16, what bulb will do? No pressure, right? Because it's sensing wrong temperature because of this line. So it will keep close your TV. So again your evaporator will stop, right? Clear?
Clear, sir.
Thus falsely influencing the TV bulb temperature. So what should be the what should be the position of your bulb? It should be like this, it should be like this, or it should be like this. Where should be the position? It should be at the bottom of the pipeline, it should be at the top of the pipeline, it should be at the sides of the pipeline. Where?
top of the top of the pipeline.
Why? That we can see in the diagram, right? They have tick right on the top. But why? The bulb is
Because
best mount. Please go ahead.
sir, if it represents a vaporized vaporized, then sir, if liquids at downside, sir, if in any chance sir, liquids are downside, vapor two phase there, sir, liquid phase and vapor phase. Vapor phase is top side, sir. So sensing bulb can get easy and sensing.
The bulb. So are you sending liquid in the pipeline? First of all,
No, no, not
No, no.
liquid, sir.
No liquid refrigerant, right?
No liquid efficient, sir.
The bulb is best mounted on a horizontal section line tube and in a position corresponding between 1 o'clock and 4 o'clock. Can you see figure number 1? It's
Yes.
between 1 and 4 o'clock. The location depend on the outside diameter of the pipeline. So first pipeline is 12 to 16 mm, they put at 1 o'clock. Second is 18 to 20 mm, they put at 2 o'clock, right?
Yes. But why, sir?
Why? We'll see
Why
it.
we?
It is coming. Just wait. Everything is coming. This is to get the more accurate reading, since should any liquid refrigerant present in the suction line exiting the evaporator, and this liquid refrigerant will most likely to be found just above the oil flow on the bottom of the tubing. So
Yes.
it's way back to the compressor. So it might be possible on bottom what you have liquid, right?
Yes.
Liquid what? Oil. And if any liquid refrigerant is coming,
Yes.
that will be on top of the oil, right?
Top of the. Yes, sir.
So we are just putting little bit up so that it can sense temperature correctly. Okay, if you are going to put on the top, then you will be only having vapors like this, right? So if your pipeline is bigger, you can just see they are coming down. If your pipeline is smaller, they are putting at 1 o'clock. Pipeline is getting bigger, they are putting at 2 o'clock. It is getting more big, they are putting at 3 o'clock. More big, then they will put at 4 o'clock.
Okay, sir.
Clear?
Yes.
Okay, guys, then that's all for today. See you tomorrow. Small part is remaining still. We'll see how unloaders are working for both, and we will see various reason troubleshooting, charging of refrigerant, charging of low boil, then psychometric chart, and then one or two question of Pakrasi sir.
Sir,
I
Santosh sir, when will you come back, sir?
tomorrow.
Santosh sir, tomorrow.
Who Santosh sir?
Yeah, Santosh sir.
Why? What happened? You are not happy with me?
No, 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 sir. Actually, sir, we have, sir, this week, sir, oral exam, sir. So,
Oral.
yes,
Okay.
sir. MEP and motor, sir. So we need to, sir, question discussion, surveyor by surveyor question, sir.
Okay.
So,
Okay. I'll ask admin to put his lecture tomorrow. Okay.
yes.
Okay, guys.